to have a theme today that's called FENIX 2025 that will present a little bit about the pilot plant that we have in our house, and we are also very pleased to be able to have one of our collaborators and customers from FiberLean Technology present. So with that, I'd like to start to introduce our first speaker, which is my honored colleague, Mattias Drotz. He's been working for our company for very many years. I actually don't even know how many years, but it's many years, and has been involved both in project management and business development towards the paper industry, and also since about 10 years back, also very much engaged with the hygiene. Can I ask you all to put your mute button on? Thank you. Can you put your mute button on? Thank you very much. Mattias Drotz is also the one that's responsible for starting a research program within the tissue area here at Bioeconomy, and that started in 2009. So this mute button actually reminds me of the fact that how we do this seminar is that you all have your mute buttons on, and if you want to pose a question, please post that in the chat forum, and we will pick that up at the end of the breakfast seminar. So we will listen to Mattias first, Per Svending then, and then we will pick up all the questions that come up in the chat room at the same time for both presentations after we have heard both presentations. Okay? So with that, Mattias, are you ready to start with the presentation?
Yes, thank you. Then I will try to share my screen here. Like this. So I hope everyone can see this presentation now. Okay, a testing facility of tomorrow. How should that look like for paper and packaging? That is the question. And I think the first thing you need to do is to look into what global trends do you have in the world, and how is that affected the paper and packaging industry. And here we have divided the paper and packaging industry into packaging, hygiene, printing and writing, specialty paper. With packaging, we mean carton board, container board, liquid packaging boards, folding box board, and those kind of products.
Mattias, sorry to interrupt you, but we don't see the presentation. Klaus here.
Okay. Is it now?
Yes.
Sorry for this. Okay.
There you go.
Yeah, sorry. Very sorry for this. If you look on the left-hand side here, you can see the global trends, and on the right-hand side, the different segments in the paper and packaging sector. And with hygiene, if I continue there, we mean toilet paper, towel, napkins, facial, and diapers, and those sorts of products. Printing and writing is more newsprint papers, copy papers, and those kind of products. Specialty paper can be a lot of different paper grades, of course. It can be paper aimed for medical industry, interlayer in between steel, for example. It can also be packaging, labeling, and all other kinds of filters and all other kinds of products. But if we take a look at some of the global trends that we see in the world, if we start with increasing global economic growth and growing population. I mean, the population right now in the world is over 7 billion people, something like that, and it's expected to grow to over 9 billion in 2050. And that will, of course, also drive the paper and packaging industry a lot. Urbanization is, of course, another thing. People are moving from rural areas into to mega cities, and that will also, of course, change the behavior on how we are using our papers. Pandemics is, of course, also a game changer. I mean, we have had the swine flu in 2010, bird flu a couple of years after that, and now we have COVID-19. And as I said, this is a game changer, and it has changed a lot on how we're acting, of course, when ordering things on e-commerce, ordering things on the internet and so on. And that will, of course, also drive different segments here, like packaging, for example. Digitalization is another thing that has been going on for a while. Paper as an information carrier are losing ground in fact that we have more digital solutions, and that has affected the printing and writing industry a lot. What we also can say about environmental awareness, and that is of course a huge area, and that, I mean, efficient use of raw material, energy, water is of course very important things to, and will change the paper and packaging industry. Sustainability, for example, is also an important thing. Plastic is replaced. We want to replace fossil-based material with the bio-based material, for example. Also, responsible use of raw material, forest is of course also very important. Responsible use in that fact that you want to also use your side streams maybe to create new products, bio-based products, that will also affect the industry. But if we look at the paper and packaging industry and looking back here, this is a graph on the left-hand side showing the trend from 1992 to 2018. And as you can see here, the global paper and paperboard market has increased from 250 million tons to over 400 million tons to 2018. So it has been a steady increase in the market. And this is also predicted to increase even more. I think it has been reported that it will be increased with even 70 million tons to the year of 2030. What we also can see, of course, is that we have a declining trend for graphic paper. You can see the growth rate figures here. For newsprint, for example, from 2010 to 2018 here, which is declining with more than 6%. And that is a trend that has been going on and will probably also continue to going on. What we also can say about the packaging area is that it has been increasing steadily and still are doing, and also expected to continue. We have tissue, for example, here also, which has been increasing with an annual growth rate of 4% annually. And I mean, if you take a look at these figures, it means that the world needs at least one very, very big pulp mill a year to cover this demand of 4% for the tissue industry. On the right-hand side here, just showing the same thing, the share of different grades. And as you can see, the newsprint grades had a larger number in 1991 in comparison to 2018. And sanitary and packaging, we have an increase. But what do our customers say, the customers that we have on our pilot and facility unit? So we asked the question here, we made an interview based on 12 interviews from paper and board manufacturers and also suppliers to the industry. And the first question we asked them was, what demands, trends do you see for the future? And here you can see some of the answers here. And of course, what our customers see is there's a switch to more packaging focus. You can also see here important things as replacing plastic with bio-based material, sustainable coatings, also with bio-based solution instead of fossil-based. Right product and process for right raw material. That can be, for example, if you're a eucalyptus producer, you want to know what product the eucalyptus should go for and how the process should look for that. Energy efficient, you want to produce your product with as little energy as possible, of course. You want to decrease your grammage. Efficient use of raw material. You also want to look into new products and functions, and increased wet strength was another thing that was mentioned from our customer. So the key learnings that we see from this is that first, I think paper making, R&D and innovation will be of importance to meet the demands of both increased sustainability, but we should also have in mind that we have an expected growth here in the upcoming years. We can also see that we have some sectors that are growing, the packaging and tissue sector, for example, and also some sectors within specialty paper. Digitalization will have a negative impact. We have seen that for certain market segments, for newsprint, for example, but digitalization will also create new opportunities, we think, in the future. Just to mention our pilot facility, which we call FENIX. We have the test units both in Stockholm. You see a picture of the paper machine here, FEX. And we have also test units in Kista and Örnsköldsvik. And within this test and demo unit facility, we have both lab scale, pre-treatment equipment, paper making, as you see here, drying equipment, and also test units for converting. So that is our test and demo unit that we have within RISE on this area. What we also asked our customers was to, do you really need a test and demo unit, or why is a pilot park of interest? And these were some of the answers that we had from this interview, where a customer think was of importance. And the upper ones here are of most importance. One thing is to have a flexible machine for process and product development. It's possible to test new testing concept and new function that is not possible on a full-scale machine. It's also an excellent tool to secure a larger capital investment. Also optimize different process units, much easier to do it in the pilot, was the answer we got. You can also produce demo materials for customers, and that is mostly for suppliers, maybe. And you can have more material, of course, in comparison to lab trials. Of course, what we also wanted to know, what are the limitations of our test to demo unit today? And here were some of the answers we got there. Comments regarding the speed is not high enough, better drying capacity, better grammage control, variation in dryness was some of the comments. Insufficient capacity when it comes to adding additives. Not enough trial points per day was another thing. Some were also asking for more converting possibility, and the last one here, we also got the comment that there are too many rebuilds, which will make the trials a little bit too expensive. So for this reason, we have been looking into this, and we have been running a project which we call the baseline project, where we're looking into how can we secure the runnability, the watering capacity we're also installing a new control system, and we're also looking into how we can increase the machine speed of, if we take the FEX machine as we see here. Another thing to avoid the number of rebuilds, we're also looking into a new approach on how we can work, divide the year into blocks for the trials that we're doing, for example, to minimize the rebuilds. We are also discussing here major rebuilds and by customer request, and that is of course possible, and for doing that we also need to have customers on board for bigger or larger investments. So from here on I will just show some examples what we are working with and what we have worked with here over the years when it comes to those areas here. If we first take the upper one here, new products and function. This concept was developed, let's say if you have a product which is special and you have a limited amount of material, then we have developed the concept which we call pulse production. With this we can have an assisting pulp where we start the trial with, and then we pulse in the specialty paper or the novel raw material step by step, and at the end we have 100% of the specialty paper. So that reduced the amount of material that we need, and we can run the trials in commercial-like conditions. Right product and process for right raw material. Here we have a concept where we have been running a concept with a high wrapping angle for board application, and this concept has been developed by customers and is also now available for others to run and try. And this concept has also been the base for a bigger industrial product that is running right now in the world. Decreased grammage is another area that we're working with. We have our mobile MFC units where we can produce strength additive on site. So here we see a picture where we are unloading the container or the mobile factory at the mill. And here we have some results. We have five or to six different products that we have been running on site, and we have some references where we have decreased the grammage with, and thereby saving money for our customers. Decreased grammage is of course something that we are doing also on our paper machine, and we have been working a lot with us for different board qualities, and we will also hear from the next presentation another example, not maybe decreasing the total grammage but the fiber grammage, and then produce products to a lower cost by with FiberLean we'll present here afterwards. Tissue is another segment that we are working with, and here we have unit processes. Here's an example where we have produced strength additives on site at RISE, and then we're unloading the MFC in the tissue mill to change the fiber mixture and thereby producing a cheaper quality for the customer. We also have a unit, a creping unit that we have developed in one of our test units. Other areas, sustainable coatings is also another area that we have worked within. And here you see an example where we are coating with a biodegradable or biopolymer, just to see if you can replace a fossil-based coating on the board. So this is another area or test unit that we are running products on right now. New products and functions. We have also the testing unit, the XPM machine up in Örnsköldsvik, which you see a picture of here. And this unit has been developed to look into different specialty products And here you see an example of nano paper, for example, with fire retardant properties. And there are much more things that has been done on this machine. And finally, also in the area of digitalization, here we have ongoing project. We're working, as you can see here on the picture, with cameras, augmented reality and virtual reality. With this augmented reality, we can use camera to have overlaid information, for example, and guidance when you come to a point in the machine and you want to do something, and then you can get instructions in the camera. So that is something that we are working and developing together with our customers. Remote monitoring is another area. For example, remote monitoring of valves in the machine, and then have services doing in-cloud services combining with other data. It could also be. Product variability is another area that we are working within. And here we have our outliner where it's possible to run with paper rolls, so we can get the variations in the machine direction by doing this. And also connect this data with your DCS or QCS data, and thereby developing soft sensors at the end. Digital twins, the last picture that you see here in the corner, right-hand corner, it's another area. And here we have an example where we are at a laser scanner that is positioned at the back of the machine, and thereby creating a digital twin of the paper machine. And that we have been doing in a project, and I will now show an example of this. This is a recorded video. So, but what you can do here is that you can sit in front of your computer, and then go in to certain points in the machine, looking into details. You can be at different positions. Let's say if you have a customer at the other end, or another place, you can show him with this digital twin different things that you want to discuss maybe. You can also see here there are markings on the machine here. We have markings here at, I think we had 6 to 8 positions where the 3D laser was scanning, and then it was merged to one digital twin, as you can see here. And what we hope to use in this for, there are of course a lot of areas that you can think of. One thing is, for example, for education. It could also be when you have, like now, restriction to visit mills. You can have your suppliers using this to show things for the operators, and the operators can also show things for the suppliers if there's something that need to be fixed, for example. What you also might think of here is to have this digital twin and have it combined with AR. We are not there yet, but let's say if you have it for education and you come to position in the machine, and at a certain point you can have instruction on what is this, and let's say if you wanted to have some instruction to perform something at a certain point, that could also be possible. We hope here in the future. So this is something that we are working, and as you can see here, we are working. We have scanned the machine in all levels, so now we are down here at the basement. So I think I will stop the video from here, and I think also my time here is running out, so I will just conclude it. So what we are trying to aim here for the future is continue to focus on emerging market segments, especially the board sector, specialty paper, and the tissue sector. That will be a main goal, I think, for us here, and also continue to develop the facility towards resource-efficient production and also sustainable solutions. What we also aim to do here is to look more into digital tools and solutions, which we are already working on. So that is the end of my presentation. So thank you very much, and I think I will.
Thank you, Mattias. Thank you very much for a nice presentation. And for all of you who have questions to Mattias, please use the chat and we'll come back to that. But now we would like to continue with the presentation from Per Svending. And he has actually been using the facility, right, Per?
That's correct.
Yeah.
More than we would have wanted to.
Oh, well, yeah.
It took us longer.
But I just wanted to briefly present who you are. You are working for FiberLean Technologies nowadays, but you have 40 years of experience in the paper technology, both as a supplier in a very broad field, I think. So it will be very interesting to listen to your takes on what you can do and what you can't do, and a little bit specifically about the application that you wanted to reach. So please, Per, the floor is yours, or the digital platform is yours, at least.
Okay, thank you, Pia. Let me now see. Can you now all see my presentation? There. Is that visible now?
Yes, it is. Perfect,
Good.
Per.
Thank you. Well, thank you for having me. I have a story here about development of a new concept, a concept of wet end coating that we have run on the FEX machine. For those of you who do not know us, FiberLean Technologies, I can say that we are a technology joint venture owned by Imerys and Omnia, and we are working with nanocellulose developments. So the system that I'm talking about, we refer to as FiberLean on top. So with wet end coating, we mean an application of a coating made up of white pigments and MFC as a binder on top of the still consolidating base paper right after the wet line on the Fourdrinier table. So this is really something that hasn't been done in the past. For us in FiberLean Technologies, behind us we have a commercial process for making MFC, where we currently have 5 operating plants with a combined capacity of 12,000 dry tons of MFC per year. And we have quite a lot of experience of using MFC in paper making, but as a wet end additive. And we saw that there were opportunities to use this in coating if you could only overcome the issues associated with removing all the water, because as you all know, MFC carries a lot of water. So we started out in lab scale evaluating what could be done with this type of technology. And we went on over different types of pilot machines, starting up with slow scale, and eventually we turned to RISE. The picture that I've used to exemplify this is from our first slow pilot machine trial. As the optimists we are, we could see great potential in this result, although it was quite clear that we had some further work to do in getting an acceptable evenness of the coating. We also could see that the basic paper properties that we could achieve with this type of wet end coating were very interesting. We could reach the levels of brightness that are typical for white top liner at relatively low coat weights. We had a profound impact on the porosity of the sheet, which is interesting, and we improved the roughness a lot. Scott bond remained constant, which is a great result because it indicated that the break was not happening in the white top layer. It was breaking in the base. And we came up with results indicating that we have a concept here that can be quite competitive with normal ways of making white top liner. So instead of putting something like 45 grams per square meter of white top on a base liner with typically something like 15% filler, you can use only 30 grams and you have 80% filler in that and 20% MFC. So a profoundly different formulation, and one that can give substantial savings in operating cost. It's also interesting to note that the amount of white fiber that is needed is dramatically different. In the conventional white top, you needed, in this example, 38 grams per square meter. But in the trial material, we only needed 6 grams per square meter, and that's the white fiber we use to make the MFC. And of course, in today's world, where the demand for white top liner is still growing quite rapidly, and there's a reduced amount of recycling product coming from printing and writing papers, this can be quite important to maintain good recycling balance. The biggest saving associated with this type of technology, however, is that you do not need to rebuild your paper machine for a second layer. You can get away with a much lower capex applicator that you need for applying onto the surface and using the existing equipment for removing the water. As I mentioned, there is growth in white top liner, and it's an interesting market and one that I've had reason to look more deeply into recently. It is viewed by a lot of brand owners as one of the last advertising frontiers where people have difficulties switching the message off, as they have the opportunity to do in many other areas. And a lot of effort goes into using packaging for advertising today. And this means that there's growth in volume, and there's also growth in demands for printability and flexibility in what you want to print. And this calls for new print methods and higher demands on the substrate. And actually, it's a tough statement, but the current white top liner simply isn't good enough. If you look at the quality ladder that I try to portray here, as you move up towards higher quality demands, people are, to a very large extent, moving away from white top liner products and instead use graphic board to laminate or graphic paper to label on top of the corrugated board. So a substantial part of the demand for high quality print surface is actually not met by white top liner at all. It is met by graphic paper and board. And of course, this is adding a significant cost and complexity in the manufacturing. Early on in our development, we established a cooperation with a very competent supplier of industrial inkjet equipment. So we've been using their facilities to test our different prototype papers. And this has given us very interesting results. With an MFC pigment coating, you have many options to vary the printing properties through choice of pigment and the pigment particle size, particle shape, etc. And it's quite easy to tailor it to fit into the needs for inkjet, for example, as this supplier is interested in. And the results we have achieved have been viewed as nothing short of spectacular. We get very nice print results, and with quick ink drying, avoiding the issues with smearing that is a frequent problem when printing inkjet. So with that background, it is clear that we had a very high motivation to solve the issues that we were expecting to see when we scaled up our process from being run on slow pilot machines to high speed. We knew we were onto something that had potential, but we also knew that we had some significant challenges. The picture here is one taken in one of the containers at RISE as we're starting one of our trials, and you can tell this is fairly viscous material. It has a viscosity similar to peanut butter. And to apply this at high speed onto a paper is a challenge. Diluting it is not a good option, as dewatering is clearly one of the limiting factors here. And we can't reduce the coat weight because we know that we need about 30 grams per square meter to get the optical coverage to reach the normal level of brightness that you want on white top liners. And we are applying at a position that is really sensitive to disturbances. If we get it wrong, we know we will break the sheet or at least damage the sheet in an unacceptable manner. And the water removal has to happen on the second. So we went at this obviously with the aim of sorting it out in 1 or 2 trials, but we didn't. We needed 8 trials on FEX to get to where we wanted to be. And we were trying to minimize the number of trial points as much as we possibly could, although there were only a few things that we wanted to keep constant, and that was basically speed and grammage. And everything else we needed to check, at least as variables. So things like the base paper, furnish composition, the coat weight, solids of coating, and so on. To our help, we used short exposure photography, because it is impossible to the naked eye to understand and see what is actually happening when you apply this onto the web. The picture here is a real live picture from the FEX machine, where you can see the jet of coating being applied onto the base paper. And it looks very nice, doesn't it? But it's not the full story. When you actually use a camera to capture what's happening, you can see things like this, which is obviously totally unacceptable and will not produce a good quality. And you can see things like this, where you see a coating jet that is quite acceptable, but you're coating onto a very rough base with poor formation. And that will not give a satisfactory result either. And you can pick up things like little holes of air coming into the coating. And you can also look further down the table to see what the more consolidated coating will look like before you go into the press section. So it's a very useful tool, and it allows us to make quick changes based on what we're seeing, rather than waiting to analyze the samples and take decisions after. So through this, we were able to screen out a lot of things that had no potential of being successful and focus on things that could. So it was only in our 7th trial that we felt that we had a real technical breakthrough. And some of you may have seen this. We tried to spread the word out that we had successfully produced a good coating with FiberLean on top at 500 meters. We did a lot of development of the equipment in parallel, and it was actually using our 5th applicator design when we ran that trial and had a technical breakthrough. This prototype that we are still inclined to be using is also one that we have turned into full-scale drawings and are ready to manufacture in full scale for full-scale trials now. And we have been operating this extensively offline. That means not on a paper machine, but in our pilot plant where we can collect the material, but we can study the stability of the jet and make sure that it operates well at different speeds. And we have confirmed good operability up to 1200 meters a minute now. So that means that we have quite a wide area that we can operate in. We went back to FEX in March of this year to try to get all of our acts together, and we produced paper with this process onto a 70-gram OCC recycled fiber base, so a very realistic base, and managed to produce acceptable formation. We had very good holdout. You can see the cross-section picture there with the coating nicely on the surface of the paper. We could size it to an acceptable level, and we reached 80 brightness. We had no streaks, no air bubbles, no pinholes, but we did still have some felt indentations from the press section, which has been a problem, and one that we think can be solved by using finer press felts. Overall, this was a really good results, and for us, this has been the proof of concept for wet end coating. Now, water removal is key to making wet end coating work. And here are some solids data from the same trial point you saw on the previous slide. And I have, for confidentiality reasons, I've taken off the scale on solids content here. But to give you an idea, on headbox and coating solids, I'm comparing the below 1% solids that you apply in the headbox for the base paper with something that is close to 10% solids of the coating that is being applied on top. And when you measure the solids content after the couche, it is clear that you lose a few percent of solids when you have applied this coating. On the other hand, after the press section, you end up with a few percent higher solids. So in terms of being able to dry this paper, you should have advantages rather than disadvantages. The challenge is that this process is quite demanding on the press section because you clearly increase the need for water removal in the press. And this is the press section on FEX. And here we had issues in our earlier trials in that particularly the second press was difficult for us because the only way to get water out of the paper there was to push it through the very low porosity coating, and that wasn't doable. So we had to run with a second press at almost zero pressure to avoid damaging the coating. And more or less remove all the water in third press, and that was giving us severe limitations. But fortunately, RISE were able to fix this, and they've arranged double felting on second nip, which allowed us to run this at normal pressures and take out water there without disturbing the coating. And I would say this was key to our ability to be successful in our trials on FEX. We have identified a few other potential improvement areas for FEX as well during our trials. We're not entirely happy with the formation on the Fournier section. We know that the gap former is a lot better, but we had to run the Fournier. And of course, using all long fiber furnishes didn't help. So that's an area that could be better. We are very sensitive to basis weight control when you try to produce a 2-layer sheet, and that could clearly be better than it is today. We wouldn't mind having a more powerful vacuum system to help getting higher couche solids. And the flexibility of the press section has improved a lot now. But I think given our sensitivities, we would love to see it even more flexible. And last, but perhaps not least, the quality of the dried reels has been a limitation for us in that the edges of these reels are quite rough and not very flat. And if you want to evaluate in inkjet, where you have a sensitivity for damaging inkjet heads, if your reels are not very flat, it's actually stopped us from doing that in reel-to-reel inkjet testing. So we feel that we are ready to roll this out now, and we have lined up some partners for further full-scale trials. In the meantime, we have also worked on regulatory compliance, and we have what is needed to go ahead and launch this into the market. And armed with the spectacular print results, we feel that we have something that is ready to rock the market a bit and offer a new way of producing white top liner that is going to be lower cost and produce coated white top liner quality with uncoated white top liner drying rate. RISE has shown good flexibility, and they've been very helpful in adapting to our sometimes rather odd requests. And we're happy for that, and we'd like to say thank you.
Thank you very much, Per. That was your last slide. That was a nice slide. That's an interesting presentation you had there, and an interesting product. I'm very happy that you shared that with us today. Before, I haven't seen any questions from the audience yet, but what I'd like to know, Mattias, if you could comment a little bit on the limitations that Per mentioned on what's the status today on the limitations on the pilot that he mentioned. Can you say a couple of words on that?
Yeah, I think I mentioned it a little, but we have this baseline project that we are looking into. Those kind of issues that was raised here. So that is an ongoing thing that we are working quite intensively with on the machine. And we have fixed some of the things that was mentioned here, but of course we still need to do some more things here. Absolutely.
Somehow I think to us it's so essential that we have this type of a collaboration that you represent, Per, because this is how we go back and forth in relevant questions. So I think that's very valuable for us, at least. My question to you, Per, is how do you see the role of a pilot machine like this? Could you have come to the launch of your product without trying this out on a pilot scale like you just presented?
Probably not. I think some of the mistakes we have done on FEX would probably have thrown us out of most paper mills, to be honest. And besides, there are obviously costs involved in building applicators and things. And the wider you go, the more expensive they are. So it's bad enough to produce equipment that can be suitable to run on FEX, but to speculatively build for building, going to full scale and then go out without having any prior experience, it's too risky. I think you clearly need an intermediate step. And in our case, there was absolutely no doubt that evaluating at low speed pilots, which there are plenty of, was not sufficient. The real challenges started only when we brought the speed up.
Mm. Well, that's interesting. I'd also like to ask you another question, Per. Do you see any potential at all with what Mattias showed on this digital visualization of the machine that he was talking about at the end of his presentation? I mean, now in these Corona days, what do you think? What's your take on that?
Yeah, I mean, today, I can see that we have possibly good reasons to come back to FEX to run demonstration trials for specific customers in the future, where they want to see this being done on their particular furnish and with their requests for pigment mixes and so forth. And today, given the pandemic, you're not going to have people travel to Stockholm to look at that. I was impressed with the quality of the 3D model here, and if you could run trials and show them live to customers and using this as a background, I think that might be a path forward.
That sounds good, Mattias, doesn't it?
Yeah.
Okay, so we have a question here from Maria Lopez. Could you comment how you solve the issue of high viscosity of the coating formulation in curtain coating? And I suppose that's for you, Per.
Yeah, MFCs are extremely shear thinning. So it's a question of managing viscosity through shear in a clever way through the process so that you can get away with it. I don't want to go into more detail than that for obvious reasons.
Well, that's great. I can also say, Per, that you have some cheering hi and thanks from the team at FEX in the chat room, just so you know, because I think you actually work very well together. And I suppose that this is one thing that at least I think is kind of interesting. It's not just us that work, we work together when we have a project like this, and that's very important to remember. So I don't see any other questions in the chat room at this point. Mattias, do you have anything that you would like to add? We have a couple of minutes left before we go to the final part of this breakfast seminar.
No, I mean, not more than that. I mean, if you have questions, just contact us and we can also transfer you to the right researchers and so on in different areas. So please welcome to contact us afterwards here if you have any further questions as well. Absolutely.
This is Torbjörn Wahlström here. Is it okay to also ask a question verbally?
It's very nice to hear your voice, Torbjörn.
Thank you. I wanted to start. I tried to start the video here so you could also see the digital twin of Torbjörn Wahlström, but okay, you have to be satisfied with the voice here today. So actually, when I read this invitation here, it was FENIX 2025 pilot transformation and from printing to packaging, and I don't know if I missed something, but So what will FEX look like in 2025? What kind of packaging boards can we make on the pilot machine?
Yeah, well, I think it might. Yeah, of course. I mean, board is absolutely a very, very important area and thing for the machine. But we also want this to keep it flexible, I would say, also, as we have many application or trials that are not directly maybe towards board applications. So the title might be a little bit misleading, as we also aim to look into other grades for specialty papers, for example. When it comes to how it will look in the future here, I mean, what we are launching now is this kind of blocks, for example, and that will also give us some feedback on what is of interest, and we will try to adapt after that, I would say, to a lot, or so to speak.
Can I add something, Mattias?
Yeah, please.
Because that's absolutely true. But when we have been talking about transformation from printing paper to packaging, it might be a little bit too tough to say that, because FEX is and has always been a flexible pilot machine where you can rebuild and do different things depending on what the demands are from the customer. What we have realized is that printing paper is kind of it's not growing. It's rather the opposite, as Mattias showed, and packaging is an area that we have to be able to take care of a little bit better than we can today. So therefore, we have realized that we need to make some changes on the machine to be able to run faster and with other grammages, so that we can meet the demands. It will still not be, like a full-scale packaging machine, because that's not what we're aiming for. We're aiming for the pilot machine. But there are some things that the customers has told us that we need to look for if we should be able to make more pilot trials for the packaging area. Am I right about that, Mattias?
Yeah, I think I agree with that.
So I see no further comments in the chat room, and therefore I'd like to try to turn to our last little piece of the breakfast seminar. For you who have participated in the breakfast seminar before, you know that we would like to finish up with you taking out your smartphones, and we'd like to have just a little bit of a Menti quest for you. And while the operator is setting this up, I can also say that for all of you who have participated, we will send you an email of with the contacts of the people that you can contact around this, and also you will get a link to where you can find the presentations and so forth. So you will have an update. So please take out your phones and dock into menti.com and put in the code. You see the code up there, 5774744. And we appreciate if you could do this. And then if you can go to the next slide, Alexander. So, oh, look at that. You have already started to give us some feedback. We have actually tried to collect this feedback since the very start of these breakfast seminars to see what works and what doesn't work, and to also give some feedback to the presenters, and we'd like to see how we can make this better. We can take the next slide. You can still do that. The other information that we are eager to get your feedback on is where you heard about us. That's also useful for us. And the third question, we will have these open, all three questions, we will have them open. The third question, Alexander, if you change this is, if you have any feedback on today's seminar or ideas for future topics or something like that, we appreciate very much if you could put them in here. And that also goes for you, Per. If you have any, if you have your smartphone up, it's very valuable to get some input. And while this is being fed in to the chat room or the menti.com, I can also say that we are planning to continue our breakfast seminars next year, and we will probably have about 4 during the year. This year we had 6 because we had 2 extra interesting topics. So we are looking for interesting themes, and we will definitely invite all of you that have shown interest to come back and listen to us. And it seems like barrier coatings, we can come back to that. And that you would like to come back to that too, Per, wouldn't you?
Yes, absolutely.
Yeah. So
one of the areas we were very interested in.
Yeah, right. And we have had a seminar on barriers, but I think the interest is so large for that area, so we could definitely come back to that. And also I can mention before we close today that if some of you are collaborators or customers to us and would like to join us in a breakfast seminar, please contact me or Helena. That would be very possible in the future. With that, I think it's time to actually close for today, and I thank you very much for your interest and hope to see you at the next breakfast seminar. And thank you, Mattias and Per, especially.
Thank you.
Thank you. Thank you.
Okay, thank you. Bye-bye.
Bye-bye.
Bye-bye.